Okay, in this vectors question, you've got a parallelogram and some information you're told is O to A is A and O to B is B. I'm going to mark that on. O to A is this vector, is the vector A. O to B is this vector. Mark that on. Points M, S, N, and T divide O, B, B, C, blah, 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 and the ratio is 1 to 4 respectively. So you can kind of see where that is from the diagram. If I kind of mark those numbers on, that means that would be in the ratio 1 to 4 there, 1 to 4 there, 1 to 4 there, and 1 to 4 there. So that will help us with splitting up some of the vectors. So the first question says, can we express M to N in terms of A and B and S to T in terms of A and B? So let's look at the path M to N. M to N is here. How could I get there? Well, I could go M to B, then I could go B to C, and then C to N. So let's work those out. So the vector M to N is the vector M to B, B to C, C to N. The vector M to B is part of the vector B, and it's actually 4/5 of the vector B. Because it's in the ratio 1 to 4, it's 5 parts in total, so that means 4 out of the 5 parts. B to C is parallel to the vector A, so it's the same vector. It's vector A. This is because of the parallelogram, we know that. And the vector C to N is one of the parts actually going in the opposite direction to B. So it's parallel to B, but it's going the opposite way. So it's minus, and it's actually 1/5 of B. So all I have to do is simplify that, which is A plus 3/5 B. So that's part A. Part B is to find S to T. So let me just get rid of these green lines. To find S to T, I need to go there to there. The one way I could do that, it's not the only way, but I could go from S to B, and then B to O, and then O to T. You can go another way if you want. Vector S to T is S to B, B to O, O to T. Vector S to B is one part of the 5 from going this way. Again, that's going in the opposite direction to A, but it's parallel to A, so it's minus 1/5 A. B to O is the whole length of B, but going the opposite way, so it's minus B. O to T is 4 out of the 5 parts from O to A, so it's 4/5 of A. Simplify that. You've got 3/5 A minus B. That's part B. Part C is the bit that people find tricky, which is to show that the lines M, N, and ST bisect one another. What that means is that M to N, or rather M to D, should be half of the distance of M to N. So we're kind of saying that M to D should be a half of M to N. And also S to T means that S to D must be a half of S to T. We cannot assume this from the question because it asks us to show that they bisect each other. You can't go in just assuming that, but bear in mind that that's what you want to show, is that we've got this scalar of a half, scalar multiple of a half. In order to do it, we need to then consider how do we get to D. And you can go from any point, but it probably makes most sense to go from the origin. In order to do this, you need to consider 2 pathways of getting from O to D, one of which involves the line MN, and another pathway that involves the line ST. So, let's have a look. O to D, I could go from O to M and then M to D, so that uses the line N to N. Another way I could go is I could go to T and then travel from T to D, which uses the line S to T. So that's using the blue line. Okay, let's see what happens when we do that. So the vector O to M from before we discovered was a fifth B. Remember, this is the vector B. That's a fifth B. The vector M to D is going to be some multiple of the vector M to N. Now remember, we cannot assume that this multiple is a half. So for now we're going to call it lambda. So hopefully we're going to show this eventually. So lambda should be a half, but we cannot assume that for now. We know what M to N is, so I'm going to use that. So it's fifth B plus lambda. M to N we found in part A. It's this. And I'm going to expand this all, and what I'm going to do is get all the A's together and all the B's together. It's going to be helpful later. So all the A's is going to be lambda A, and all the B's is going to be 1/5 plus 3/5 lambda B. Okay, so that is going to be very useful later on. So bear in mind, that is one way of writing the vector O to D. Another way of writing the vector O to D is going O to T, T to D. The vector O to T, remember that's all the vector A was 4/5 A. The vector T to D, again, is some multiple of the vector S to T, or T to S. Let's call it something else. Let's call it mu, why not? And that travels in the direction T to S. So notice we're going this way. Now, if I wanted it to go the other way, because I want it to actually look like this, I want it to look like S to T, I can just change the direction of that by writing minus mu S to T. I can do that. And the reason for that is I know what S to T is. I found it in part B. So it's 4/5 A minus mu times your answer from part B, which is this. And we're going to do what we did before. Get all the A's together, all the B's together. All the A's is 4/5 minus 3/5 mu. All the B's, it's actually just plus mu B. So that's another way of writing the vector O to D. This is about half of the work, because now what we need to do is compare those two vectors in order to try and work out what are the values of lambda and mu. Remember what we're expecting lambda and mu to be? We expect them to both be a half if these things bisect each other. So a way to try and work them out is by equating the two vectors. Because they're the same vector, they take us from O to D, they should be the same. And what we're going to do is actually look at equating the A parts, so this with this, and we're going to look at equating the B parts as well, which would be that and that. So let's look at equating the A's. On the left side for O to D was just lambda. On the right side we've got 4/5 minus 3/5 mu. Okay, can't do anything with that, so I'm going to look at the B's. On the left side I've got a fifth plus 3/5 lambda. On the right I've got mu. Great, I've got two equations, two unknowns. I can solve them simultaneously. This is the kind of boring bit now, because we just need to solve them simultaneously, so I'll do that. What I'd want to probably do is take this mu and sub it in there. So the first equation for A, I get lambda equals 4/5 minus 3/5, and then sub in what I get for mu, which is 1/5 plus 3/5 lambda. So I've got an equation that's just totally in terms of lambda. So lambda is 4/5, and we'll just work this out. Expand that. Probably want to times everything by 25. Why not? 25 lambda equals 4 times 5, which is 20, minus 3, minus 9 lambda. So it gives you 25 lambda plus 9 lambda, which is 34 lambda equals 17. So where, hey, it looks like lambda is a half. So, job done on that. Now I need to find what mu is. Okay, so I just pick one of these, doesn't matter. Why don't I pick B? B looks a bit nicer. 5th plus 3/5 lambda is mu. Let's sub in now, lambda is a half. We know lambda is a half, so 5th plus 3/5 times a half is mu. 5th plus 3/10 is mu. 5th plus 3/10 is 5/10. So mu is a half. So hey. Problem solved. So they definitely bisect each other because we've shown that they're both a half. Okay.